sequences. In his first public address, the principal mentioned about the success of the recent Brigada Escuela. Because of this success, the principal challenged the students, especially the grade 9 and grade 10 students, to extend the same service to their community by having a one Saturday community cleanup, which the principal called Kilos Kabataan Project. Volunteers have to sign up until 5 p.m. for the project. Accepting the principal's challenge, 10 students immediately signed up for the cleanup. After 10 minutes, there were already 15 who had signed up. After 10 more minutes, there were 20, then 25, 30, and so on. Amazed by the students' response to the challenge, the principal became confident that the youth could be mobilized to create positive change. The above scenario illustrates a sequence. In this learning module, you will know more about sequences and how the concept of a sequence is utilized in our daily lives. Lesson 1. Arithmetic Sequences. In this lesson, you will work with patterns. Recognizing and extending patterns are important skills needed for learning concepts related to arithmetic sequences. Let's dive into our first activity entitled What's Next? Each item below shows a pattern. Answer the given questions. Number 1. What is the next shape? In the series of shapes, square, triangle, square, triangle, triangle, square, triangle, 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 square, triangle, 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 we can say that our next shape would be a square. Because if we observe that after a square, there is a triangle. But as the series progresses, the number of triangles after a square also increases. So square, triangle, square, 2 triangles, square, 3 triangles, square, 4 triangles, to be followed by another square. How about in number 2? What is the next number? In the series 0, 4, 8, 12, 16, we have to determine our next number. Notice that from 0 to 4, we just add 4 to 0 to get number 4, which is our second number. If we add another 4 to 4, we get our third number, which is 8. Next, 8 plus 4, we get 12. 12 plus 4, we get 16. So to determine our next number, our sixth number, add 4 from 16, giving us 20. Follow-up question, what is the 10th number? We have to determine the 7th, the 8th, the 9th, and the 10th number, following our patterns, which is adding 4 from the preceding number to get the next number. That is 20 plus 4, 24. 24 plus 4, we get 28. 28 plus 4, we get 32. 32 plus 4, we get 36, which is our 10th number. Let's proceed to number 3. What is the next number in the series 9, 4, -1, -6, -11? If we observe from 9 to 4, we just subtract 5 from 9. So 9 minus 5 is 4, which is our second number. 4 minus 5, we get -1, our third number. So -1 minus 5, we get -6, and -6 minus 5, we get -11. We can conclude that in getting our next number in the series, we just subtract -5 from the preceding number. -11 minus 5, we get -16 as our sixth number. We have a follow-up question. What is the 8th number? We have to determine the 7th number and 8th number. Following our pattern, from -16, we subtract -5 and get -21 as our 7th number. And from -21, we subtract -5 to get 26 as our 8th number. Therefore, our 8th number is negative 26. We proceed with number 4. What is the next number in the series 1, 3, 9, 27, 81? Notice that from 1 to 3, we just need to multiply 3 from the preceding number, which is 1, to get our second number, that is 3. And then from 3, we multiply another 3. 3 times 3, we get 9. From 9, multiply 3. 9 times 3, we get 27. And from 27, we multiply by 3, we get 81. Therefore, we can conclude that our sixth number is 243. But for our follow-up question, what is the 12th number? Since we only have the first 6 numbers, we are to determine the 7th, 8th, 9th, 10th, 11th, and the 12th numbers. Following our pattern, we just need to multiply 3 from our preceding number to get our next number. You can use your calculator to compute 243 times 3. You get 729. To get the next number, you multiply 729 by 3. 2187. To get our next number, we multiply again by 3. We get 6,561. Multiply by another 3, we get 19,683. Multiply by another 3 using our calculator, we get 59,049. And lastly, to get our 12th number, multiply to 3, we get 177. 147 as our 12th number. For number 5, what is the next number in the series 160, 80, 40, 20, and 10? Notice that we can arrive to 80 from 160 by dividing 160 to 2. 160 divided by 2, we get 80. 80 divided by 2, we get 40. 40 divided by 2, we get 20. 20 divided by 2, we get 10. So our next number can be obtained from dividing 10 by 2. Get 5. 5 is our sixth number. The follow-up question, we are to determine our seventh number, which is 5 divided by 2, or 2 and 1/2, or 2.5. The set of shapes and the set of numbers in the activity are called sequences. Were you able to find patterns and get the next number in the sequence? Let us now give the formal definition of a sequence. A sequence is a function whose domain is the finite set 1, 2, 3 up to n, or the infinite set 1, 2, 3, and so on. As in the example, domain is n and your range is represented by a of n. If your domain is 1, 2, 3, 4, 5, and has correspondence to your range 3, -1, 1.5, 10, or pi, respectively, this is a function relation. This finite sequence has 5 terms. We may use the notation a sub 1, a sub 2, a sub 3, a sub 4, a sub 5 to denote numbers in the range corresponding to our domain, respectively. In grade 10, we often encounter sequences that form a pattern such as wherein we call this sequence as an infinite sequence, where a sub n is equal to 3n plus 1. In the next 2 activities, you will learn more about sequences. A general term or nth term will be given to you and you will be asked to give the next few terms.